can you dive a bit into what are the good code practices that data scientists need to have?
For me, the most important thing is traceability and reproducibility. When you have deployed your machine learning model in any way, you need to know what code was responsible for it, what data was responsible for it, what run was responsible for it. It's just like exercising. Everyone hates exercising, I guess, but it's good for you. So the same thing about writing things properly and creating modules and Python packages and writing tests.
Shout out to the Nanny ML team. It's a very interesting tool. It's very cool to try to predict the error of your model and then based on that set up some monitoring. And I think for credit risk applications or fraud detection, it's something very important.
A year ago, I had 1,300 followers, and now I think almost 31,000. We asked ChatGPT to come up with a name for an MLOps blog for two girls that like Marvel movies. What ChatGPT came up with, Marvelous MLOps.
What's your view on ML engineer vs MLOps engineer? Why are the two different? This episode is brought to you by Training Data. If you're new in data science and want to get into the field, or if you're already in the field but want to progress, well, Training Data is the platform for you. They offer courses on feature engineering and selection, model tuning, interpretability, and much more. You will get both the math and the intuition behind each method, but also Python code ready to power your own projects. So if you're interested, visit the link in the description and don't forget to use the code AI Stories to get a 10% discount. All right, so hello everyone and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist and I will be your host. So today our guest is Maria Vechtomova. Maria is an MLOps tech lead at Ahold Delhaize, and she also founded Marvelous MLOps, an MLOps blog with lots of great resources to help you scale your ML projects. Prior to this, Maria worked at KPN, which is a Dutch telecom company, and she worked as a data analyst, a data scientist, and a senior ML engineer. And Maria also got a master's degree in economics from the University of Antwerp. So today we're going to talk a lot about MLOps. If you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right. Hello, Maria. Very excited to have you here with me today. First thing I wanted to ask is, how did you get into this world of AI and MLOps? How did you get into the field?
Hi, thank you for inviting me to the podcast. So MLOps topic is relatively new, I think, comparing to the whole data and ML space. So I started as a data analyst 10 years ago, and there was no such position as data scientist, and nowhere it wasn't really a thing. So I was doing analytics, but also quite some data science, I would say. We were building churn models and acquisition models for the business market for mobile subscriptions at KPN. And we were using R back then. So R was the language of data science in those years. And then there was a shift to Python. And I moved to another department and we were doing more research and more really data science. I was also into NLP for a while. Started learning Python and it's still Python these days. I think Python is really dominating the field. When we built our first machine learning models, there was no one who could put those in production for us. And that's how I shifted into machine learning engineering. And we also wanted to help other data scientists not to reinvent the wheel. And that's how we started looking more into MLOps. So 7 years ago, we had our MLOps framework, which was experiment tracking and model registry system. We were using Teradata as a backend for storing all the experiment information. And we used Artifactory JFrog for storing artifacts. So you could assign some attributes to those models, And that's how you could search for a model that belongs to a certain run ID, a certain timestamp. And that was pretty interesting to be busy with it 7 years ago. MLflow didn't exist, nothing really existed, so we created it from scratch. We also introduced the notion of CI/CD pipelines and orchestration to data scientists. That was not a thing. So data scientists were not using version control. They were just notebooks everywhere. Notebook 1, Notebook 2, Notebook 1000. So those things really existed. And I think still data scientists don't always follow the best practices, and we have still a long way to go to educate how to do things properly. And now I am more into the platform side of things. So over my career, I built the MLOps platform frameworks 4 times all over again with different tools. So you can see it as a combination of different elements, really. So you need to have orchestration, you need to have CI/CD pipelines, you need to have some infrastructure for training and serving your models. You need to have some data version control or feature stores, and monitoring. That's another very essential piece. Application infrastructure and ML specific level monitoring, as well as monitoring your costs and KPIs. So these elements are essential, but what tools you use doesn't really matter that much. Maybe you have better experience with certain tools comparing to other tools, but overall you can make it work with any tools. And that's what I saw when I tried to do it with 4 different types of set of tools. So back then, 7 years ago, we were using a tool called Aster by Teradata, the company acquired by Teradata. They were doing data science in SQL, which seems to be a topic again. If I look at what people talk about, especially with Gen AI, I think everyone is trying to move into this space, like Gen AI with SQL. That's what you see a lot now. So it's not a new topic. It was there 7 years ago, and also distributed machine learning. That's something that was also becoming popular. We didn't really use Aster as for machine learning models, but we kind of misused it as a place to train our models and also deliver the results. And we had Jenkins for CI/CD pipelines. We had Airflow for orchestration, for monitoring. We had Elk Stack. Then we built the same thing all over again with Kubernetes native tools. And then we moved to AWS native tools. And now at Ahold Leiser, we use Databricks a lot. So basically, we use Databricks for a lot of things, including serving now. I think it really depends what kind of team you have, what kind of skills you have, how big your teams are, to choose a tooling properly. But overall, you can make it work with any tools. And I guess that's just about the principles of MLOps and not about the tools.
Yeah, I think it's interesting, especially, I mean, first of all, lots of information there, so we can break it down a bit. The first thing that you described was you working on, basically you created your own kind of MLflow experiment tracking system. You also had your CI/CD framework. Can you dive a bit into what are the good code practices that data scientists need to have? Because I don't think it's obvious for everyone. So what are the components in this setting? And then can we dive into it? Like, I'm not sure everyone is familiar with CI/CD or with experiment tracking. So can you also explain a bit how those work?
Yeah, sure. Sounds good. So I think if you look at how data scientists start experimenting, they create a humongous Jupyter notebook. And that's already, I think, the best practice, not the best practice to have this humongous notebook. So what you could start doing from the beginning is that when you define a function or a class, you start slowly moving it outside of the notebook. At least you define it somewhere else. You start defining modules. You in the end start building a package out of it. When you are testing the function, you basically do it in a notebook, but instead of that, you could already start writing tests. Not do it after, but actually do it during the development, because you test the functions anyways, but just test it in a proper way, I would say. And that's a shift in understanding how to develop software. I think it's also something data scientists are not used to and not really looking forward to doing. But I think that's just, I guess, sort of hygiene in writing code. It's something that you, will thank yourself for later on. That's something that we just need to get in our head. That's how you develop it. And I would say that that's really important. Also, when you have pre-commit hooks, that's another piece. You need to have pre-commit hooks to make sure that you're not pushing any code that is not following the conventions that you have defined. That's something that data scientists don't always have, and that's why I think it's important to have some kind of example repository, or maybe like a template repository. That's what we also have. There are multiple ways of doing that. I think cookie cutter is not the best way to do it. There are alternatives. So for example, cookie cutter, it's very hard to get back to change the certain files, the version of the files. Let's say you have changed in your central cookie cutter repository certain files, and you want to update it in all repositories that originated from this cookie cutter. That's something that is not easy to do, and that's why there are better tools out there to deal with it. But in general, if you have a cookie cutter repository or any other repo where you specify these are the files you need to have, these are pre-commit configuration, these are CI/CD pipelines, this is the structure of your project, and data scientists can create a repository from that central repository that is already helping to follow the best practices. But I think just creating a repository from some template is not per se one of the big gains of it. So what you could do, you could go further by creating a workflow that allows to create a repository with all the permissions you need to deploy things on actual infrastructure. And that's one of the things that we are busy with, having this kind of setup. When data scientists create a repository from our workflow, it will create a repository that has branch protection rules. It will have the right structure, and it will also have federated credentials set up so that you can deploy it on existing infrastructure. And that's something that I think that's the biggest gain from it, because usually if you want to set up permissions, it will take forever. Or data scientists would have to figure it out how to do it, and it's I think one of the most annoying processes out there.
So you think it's important to invest time in creating a good template, so that data scientists, whenever they need to start a new project, they've already got all these boilerplate codes for them, and they don't need to worry about CI/CD, as you mentioned, or pre-commit hooks. So for those who don't know, pre-commit hook are kinds of checks that are made before you commit your code. For example, it can format your code in the right format, or check for errors, or strip all the cells from your Jupyter notebook and things like that. And it really makes sure that your code is in the right format. So you think it's important to invest time in creating a template. If you're a data scientist in a company, it's important to spend time on having a good template.
Yeah, definitely. And it might be different templates, because you have different types of architectures as well. Like you have models that require certain output, and the output you write to a database, or maybe you You just write it to a blob storage, or you have like a surveying use case where you need to deploy an endpoint. So for these different use cases, you may have different templates and different CI/CD pipelines, of course, to do the deployment. So I think it really depends. Or maybe one team wants to follow a bit different set of practices than other team, which is totally fine. So you may have different templates for that.
Okay. And the second thing, so you mentioned all this boilerplate code, kind of cookie cutter template. The second thing was to start having code outside of your notebook, start writing tests. Some people might argue, well, I like to do things in notebook. It's convenient. Why would I lose time cleaning my code and writing tests? So what would be your answer to this? And why is it important to basically...
Yeah, well, keep using notebooks. I mean, there is probably nothing wrong with it for a data science purpose. You can use notebooks. You just define your functions outside of it, and you just input them in the notebook. And the notebook is not anymore thousands lines of code, but it's just a very minimalistic notebook.
Mm-hmm.
So I think that's the difference, really. And why it's important, because it really helps to make things faster when you want to move it to production, and that's the biggest benefit out of it. And I don't believe that machine learning engineers should be the ones that are cleaning up the code and packaging it and writing the tests, because they are not the ones who wrote the algorithm. They don't know that much about the model, the data scientists themselves. So you will lose time there, and you may run into some errors because you misunderstood something. So these are real risks that can happen, probably not very big risks, but still you will lose time. And if we shift this kind of responsibilities to data scientists, I think everyone will benefit from it. But it's a shift in the mindset that still needs to happen.
Yeah. No, definitely agree. And I see this, I mean, especially it's fine to do something in a notebook, but then if you look back at this notebook a few months after, or if someone wants to retake your notebook, it's just a complete mess. And then if you want to add a single feature, you need to add it in multiple parts of your notebook. It's also quite bad for version tracking. Like, it's much better to have Python code. So if you make sure that your code is well packaged and in certain files, if you need to add a feature, you know that you only need to change a single function in a single file, and your notebook would still run. So it just makes things much simpler. And I think it's also just nicer when you have a minimalist notebook, as you say, because when it's a big notebook with thousands of lines of code, it's just awful and everyone gets lost.
No, indeed. So it's just like exercising. Everyone hates exercising, I guess, but you know, it's good for you. So the same thing about writing things properly and creating modules and Python packages and writing tests. It just makes everyone's lives easier in the end.
Yeah, no, definitely agree with you on this point. And so we discussed code best practices. The second thing that you mentioned at the beginning is more like the MLOps environment, MLOps infrastructure. You talk about monitoring, about feature store. What are the different parts of this MLOps infrastructure? What are the key things that people need if they want to deploy models in production efficiently?
Yeah. So they need to have some kind of orchestrator first. So you don't want your CI/CD pipelines to be an orchestrator, and I think it's sometimes misused as one. So basically, your CI/CD pipeline is just creates definition within your orchestration system, but the whole scheduling, triggering is happening on the orchestration side. And every time you want to update it, you update that trigger or a schedule via your CI/CD. So you basically just have one big overview of all runs that you have in the orchestration system. And that just makes your life easier, because if you look at CI/CD tooling, you don't really have this kind of nice overview or retry of the runs and the possibility to pass values between different steps. I think to a certain extent it exists, but not as good as it is in the orchestration tooling that is out there. So orchestration is a key piece here. Then after you have orchestration, it has to, the actual code has to execute somewhere. So it's a compute. So you need to have some compute. And the way how this compute executed can be different. So you could just use Kubernetes jobs to run some code. You could use, if you are using Databricks, it would be just the Databricks clusters that you define, and the orchestrator can be still Airflow, but probably then Databricks workflows. And you see that there is also shift happening in the workflows space. So I don't know whether you heard about Metaflow. Metaflow is a tool that where you can define your pipeline as a Python code. And Databricks is also moving towards it with their workflows. They're moving into Pythonic way of defining it. Why is it nice? Because you can do anything that Python can do. So you can define for loops, if statements, and all of that within your orchestration definition, instead of having some JSON files, YAML files that you would have to still modify depending on your environment, probably with some Jinja stuff around it. So it actually makes it really nice. So after you have the compute somewhere, and you would like to also define what step has what compute, because some steps don't require a lot of memory, some do require that. So you would actually want to be mindful about the sizing and the costs that come with it. So after you did the compute, you want to write the data somewhere, deliver your product. And there are different ways to deliver your product. It can be that you need to write to a database. It can be that you need to do SFTP transfer. It can be that you need to deploy an endpoint, or write to SharePoint, even things like that, or send an email. There are multiple ways, which I don't prefer, probably the last ones, but yeah, still some products require that. So, and depending on this delivery, you need to have some kind of framework that allows data scientists to do that easily. You don't want to have them to deploy an endpoint themselves. You want to have some tools that help with it. So I think on the deployment side, to package your model in the way that is easy to deploy, there are great tools like BentoML out there that are now, I think, becoming more popular. I haven't used that in production, but I've heard it better performing than Fast API, that is probably the most widely used at the moment for model deployment specifically. So you need to have this tool to package your model before you deploy, and then you need to have infrastructure to deploy, and that's yet another thing. So infrastructure to deploy can be different. It can be on Kubernetes again. It can be, if you're on AWS SageMaker, Vertex CI on GCP. Azure ML has also a way to deploy their models, also even on Kubernetes. Well, we also use Databricks, but it has specific Databricks runtime, so model have to be stored in MLflow if you want to deploy it. Which comes to another point, you need to have some model registry. And there are also a lot of choices of toolings in the space. So you really need to be mindful about what situation you are in, what tools do you already have, and based on that, we decide how to make it work nicely together.
Yeah, you mentioned a lot of tools there, orchestrator, something to run your code, something to deploy your models. You also need to know where the data is going for monitoring. Do you always need all of those when you deploy a model, or can you pick the ones you need but don't need all the steps all the time?
Well, I think that's a minimum things that you need to have.
Okay.
You probably always need to have it. Maybe with the registry, there are some exceptions, but I also not sure. Like, for example, for recommender systems, you want to pre-compute recommendations for your customers, and what you have in that is just a dictionary. So you may think, well, I will store it in some NoSQL database instead of registering model in a model registry, because, well, it's just a dictionary. Then you may say you probably don't need a model registry, and you just have a standard software that you deploy. There is an endpoint, and then it's just reading information from database and returning the results. So in certain scenarios, you then probably don't need that, but you still want to track your experiment. So that's probably the thing that is always must be there. For me, the most important thing is traceability and reproducibility. You need to know when you have deployed your machine learning model in any way, you need to know what code was responsible for it, what data was responsible for it, what run was responsible for it, what model artifacts or other assets were created during the whole deployment. And you want to be able to go back to the previous version of your deployment. So, and you just need to keep that in mind, and then think, what tools do I need to use to make it possible? So in the example that I had with the dictionary, where you have just recommendations on customer level, well, without model registry, you could just store it in the database and version it there. Then you don't need it. But in other scenarios where there is an actual model that you load behind the API, then it is necessary, I think, to have model registry, or you could build your own, like we did with the Artifactory. But yeah, you just need to make sure that you can track things during the whole deployment and after.
So I want to go back a bit to your career and your experience. We talked about code, best practices, the MLOps ecosystem, and the different tools you need if you want to deploy your model. Now back to your career. You've worked at KPN for 7 years. You did various roles: data analyst, data scientist, ML engineer. Can we dive into one MLOps project that you worked on there, or even at your current role now as an MLOps engineer at Ahold Delhaize? I'm keen to go more into the practical stuff and talk about an MLOps project that you worked on.
Yeah, sounds good. So, well, a MLOps project for me is just creating a framework that allows data scientists to deploy things themselves. So we had a project at KPN called Model Factory, and Model Factory is just it is the experiment tracking system that we did, and model registry, and the set of reusable CI/CD pipelines and the templates. So this is a product that you provide to the data scientists, and they need to be able to create a project from scratch and make run a hello world example as fast as possible. So instead of taking 9 months to go to production, it should be done within 1 month, so that all of the overhead that you need to figure out with networking, with security, with all other aspects that you may have, you don't need to do any of that, because it's already figured out once for you. So that's an MLOps specific project. But if you go more into ML engineering, there were use cases like fraud detection on the website. So you can imagine that people want to buy a mobile subscription, and in the Netherlands, with a mobile subscription, you can also choose a phone. And it's basically a loan that you are taking, because you pay off the loan every month by just paying for your subscription. And what people do a lot is that they just order it and they never pay the bill. So basically they have a phone for free, and we want to prevent that from happening. And that's a model that we had on the website that the front end team was calling. And that's a critical model because if it was not running, it would cost us 10,000 euro per hour. And that was an interesting experience because not for all the models you have this critical production situation, right? So for most of the models, like quick managed systems on the website, well, it depends on the website, obviously, but let's say for food retailer. So I work for Ahold, Delhaize, and it's 19 brands, and most of them are food retailers. So if a recommender doesn't work on the checkout page, on the product detail page, well, it does cost some money, but it's not that as critical as it was with the fraud detection case. And here you need to have some agreements as well with the support teams on how to handle these situations, and when you also need to act as support during the weekends or outside the working hours. So those experiences are also quite interesting, and how you arrange this kind of setup.
And so your role there, was it to build the model, or was it to deploy the model in production, or was it a bit of both?
I started as a data scientist, so I built the model, but then we figured out there was no one who could put that in production, and we teamed up with software engineers within the organization to help us to deploy it. And that was the first endpoint that we ever deployed. So that was an interesting experience, actually, to do that and figure it all out on ourselves.
Okay, and then what are the things you did to make sure that this fraud detection algorithm would not go down or would not mispredict? Because you mentioned it could be very costly if the model was down. So what are the things you did to make sure it would stay robust?
Yeah, so you have, so it really depends on how your infrastructure is set up. So we didn't own the infrastructure, and the infrastructure monitoring was happening on the side of the infrastructure team. But when it comes to application monitoring, it was on our side. So we had logs coming from Kubernetes. We had everything was coming to the Elasticsearch index, and we had the Grafana dashboard on top of that with errors and the latency of the models. And if we had too many errors of certain type, it would give an alert, send a notification to us to go check it. And also to the support team, so that they could also go and check it when it was when it was outside of working hours. Also, the team that was calling our endpoint had a backup, so it was another old model that was provided by another supplier that could be used as a backup if our model was not responding. So we made sure that we probably did lose some money, but not that much. And anyways, in the night, the risks is smaller because who is ordering mobile subscriptions in the night anyways? Not so many people probably. So so it really depends on your application. I think if we are talking about, Google or Amazon or companies like that, they have much more robust systems in place. So you just need to think what does make sense for you, for your use case, and it's basically going into site reliability engineering here, how to make it reliable. But for model-specific monitoring, we did have real-time monitoring in place, where we we were looking at how errors were behaving over time. And we also had another system in place that was checking the performance after the fact. So we basically knew that person who did not pay for the next month is likely to be a fraud or had a delay in payment. So we had different setup like that, and you have to wait obviously for a month before you knew. So that is another process that you run and see how that is behaving.
Yeah, so there is performance monitoring, like you need to know if your model is still doing well, because performance can degrade over time. There is also this downtime thing that you mentioned, so making sure that your model keeps doing prediction. For the performance thing, you might need to wait a bit, but when your model is down, is not making predictions, and you should know it right away. So this is where you set up this alerting thing, I guess. Did you also monitor the features, like the distribution of your features and data drift, or was this something that you didn't do? Because I also worked in credit risk company, and I know we were paying also attention to the input features, making sure that the distribution of the training data and of the inference data isn't too different. Otherwise, it's kind of a sign that our model will not perform very well.
Yeah, so that's something that was implemented after I moved to another project that was focusing more on NLP. But I believe that there are also some distribution checks. The problem is with just checking the distribution that when it's not bounded to the target, then you may have false alerts. So there was some distribution change, but it didn't affect your target variable. Then you just have alerts and it didn't cause anything. So that's why there are different types of algorithms to check whether there was an actual drift. I think there is a nice tool specifically for that is called NanyML. I really like the open source product. So for regression use cases or for classification use cases, you can have a nanny model that is basically predicting the errors on your incoming data. So what does it mean is that let's say you trained a regression for demand forecasting, and you know already what your predictions are, and then you are training another model on top of that to predict the errors. So you know the actual errors for your model. So then you train with the same features what the errors would be. And then on any new data, you predict the errors and you compare. And if the errors are higher than the average error is higher than your threshold, for example, you could set up an alert. That's actually pretty nice and pretty interesting setup, that you could have.
Yeah, shout out to the NanyML team, because they actually came a couple of weeks ago, give a talk at Artifact where I work, and I think it was a very interesting chat, and it's a very interesting tool actually, because I worked in credit risk and we didn't use this tool, like we didn't know it exists, but it's actually a very cool thing to kind of try to predict. Yeah, maybe it didn't exist, and it's very cool to try to predict the error of your model, and then based on that set up some monitoring. And I think for credit risk applications or fraud detection, it's something very important, because as you mentioned, you only know the performance of your model a couple of months couple of months after, and so you really want to make sure your model doesn't mispredict for a month, because that can be very costly.
Yeah, indeed. Now, and going back to this fraud detection case, so indeed NanyML didn't exist, but we were looking at actually what the probabilities are, and if there were more. So you could see the distribution of how predictions go over time, And if there were more predictions on the fraud side, that's something that we're looking at, that maybe something is wrong. But we didn't have robust systems like that. It was more a manual approach, I would say.
Yeah, but anyway, yeah, I think that makes sense. And monitoring is, I mean, the key conclusion is monitoring is key, and make sure you monitor your model really well. It could be performance, latency, input features, do what makes sense for your use case, but make sure you monitor them, because if they're not monitored, you can have something in production that doesn't perform well, and that's very bad. I think, yeah, the difficult thing with machine learning is not like software engineering or like when your code runs, it usually runs. Machine learning, like your code could run, but you can have one day a very good model and a few months later a very bad model. And so if you don't carefully monitor that, it could be, things could go very bad.
Yeah, definitely. And I think that's an underestimated piece of deploying machine learning models to production.
I want to move now to content creation and your blog. So you've got a blog on Marvelous MLOps. Can you talk about it? What are you doing? What's Marvelous MLOps? What kind of content is there, and why did you create it?
Yeah, for sure. So we created that a year ago with my ex-colleague Bashak. So we worked together at Ahold Delhaize back then. She's working at Booking.com on feature engineering and with the ML platform team there. And we started that because we had a lot of ideas. So we already went to a lot of conferences, and we had a lot of internal information that we gathered within our organization. And we haven't seen such information outside, and we wanted to start sharing that. So that's how we started writing a blog. But when you write a blog, you need to promote a blog, and that's another piece, which is, I think, probably just as important. And then you need to build your audience on LinkedIn, and that's what we also started doing a year ago. A year ago, I had 1,300 followers, and now I think almost 31,000. So it's something that I'm actively doing, posting every day, and that's a lot of work, but it's something that I really like doing, and I believe in spreading the knowledge, and I think also help to motivate other people, because I know that other content creation motivated me to do that. So it's I think it's nice to pay it forward, I guess, in a certain way.
Yeah, that's an interesting thing, because I actually did the same. Like, I started this podcast, and then I was like, okay, I need people. If I start a podcast, I want people to listen to it. So how are people going to listen to the podcast? And so I started posting on LinkedIn, because I said I'm going to have followers, and the more followers I have, the more people will listen to the podcast, and podcast will also bring me some followers on LinkedIn. And so that's how I started. So I think posting on social media is a great way to market your product in some sense. One question I have for you here is, I see you're posting a lot, like even twice a day sometimes. How do you do? Do you not feel tired sometimes of posting so much? Do you not feel a pressure that you need to post constantly, or do you really enjoy it? How do you feel?
Well, that's interesting. I think in the beginning it was quite hard. Actually, when I started, I didn't post every day. I just posted once or twice per week from April until June. And then in June, I met Zach Wilson in San Francisco, and he has many, many followers. And it motivated me actually to start posting daily. And starting from July, I started posting daily on LinkedIn. And well, the more you post, the more content you see in anything. Like any discussion that I have with colleagues or any live situation that I have, I just immediately think, oh, that's a nice content piece. And I write it down, and I have a list of like more than 200 items that my ideas for writing a post. And then, well, I could do much better in content planning, I think. But basically, in the morning or in the evening, if I'm preparing something for the next day, I'm going through this list and write about what I feel like to write about at the moment. So yeah, and sometimes I just write at the moment if I have time. When I get an idea, I just immediately write the post about it. So that's, I guess, another way of thinking that you create by posting that often. And I wouldn't say it that hard. Of course, when you just have a lot of other things going on, then it's, well, I took a break also for 4 days. I didn't post anything. You need to have those breaks because you come back recharged and you feel motivated again. But yeah, overall, I think it just becomes part of your lifestyle.
Yeah, actually, it's funny because my story is similar to yours. Like I started posting once a week, and at the beginning, it's even once a week, it's difficult. You're like, what am I gonna post about? I don't have anything to talk about. But then the more you do it, the more your brain knows, okay, oh, now I have an interesting story. I'm gonna write it down. It could be a good post. And the more you do it, the more posts you can write. And yeah, then at some point I posted 5 days a week, but that was actually too much for me. So now I went back to 3 posts a week, so once every 2 days. And what I do is I also have a list. I write all my posts, but I like to, on my list, I will only have a few keywords to remember what I want to post about. And then on Sundays, usually I take 1 or 2 hours. I sit down and I write a few posts, like 3 or 4 for the week. And so that's during the week. I don't really need to, I can focus on work and don't need to write the post. They're already written. I can just fine tune them, modify them. So that's how I do. But yeah, I think we've got a kind of similar story otherwise. So.
Yeah, indeed. And you can also, use your old content, because I think at the moment I have more than 300 posts that I wrote on LinkedIn over the year. And I never repeat, actually, except maybe a couple of posts that I repeated, but most of it is not repeated. So now I'm thinking to reuse all these old posts that I have. And now I have more experience, so I could, twist it a bit and, write a better version of it. And I think also over the time you learn what your audience likes. Types of posts that perform the best. For some reason, my most popular posts were about data engineering. And I have 2 posts, one about SQL versus PySpark, and the other one is about big data being overrated for machine learning and analytics specifically. And well, people, I guess not everyone agrees with these statements. And then you get a lot of discussions and comments, and those posts get viral.
Yeah, it's often the ones that you don't think will be very viral that become viral.
I haven't expected at all, no. So other posts that I think are also quite popular is about the machine learning materials, learning materials. People never have enough of those. So, and that's also always fun to look what's happening in the industries. I anyway have these lists myself. So just sharing those versions once in a while, it is actually quite nice. And we also created a roadmap for MLOps. It's on our Substack. So that also might be nice for people looking to transition into MLOps, to look at it and follow the courses and read the books that we suggest to read.
Yeah, sounds great. I will share a link on the description to Marvelous MLOps. I checked the blog post. It's actually very nice. And I saw at one point you make the distinction between ML engineer and MLOps engineer. And for me, it was just always the same job. I didn't think about the difference. Can you explain a bit, like, what's your view on ML engineer vs MLOps engineer? Why are the two different?
I know not everyone maybe agrees with that. But ML engineers, in my opinion, are people that are working on the project level. So often you don't maybe even have a separate machine learning engineer, but you have more like all-around data scientist. So that machine learning engineer is focusing on optimizing your project, making sure that it fits within the requirements for latency, as an example, and also make sure that there is connectivity that is needed for that specific project. And the MLOps engineer actually builds the tools that the ML engineer is using. So in all organizations, you can imagine that there is a lot of overlap in the use cases. So if you are working in the retail organization, everything you have is recommender system, pretty much everything. So, and you use the same type of infrastructure for all of these use cases. And even for most of the use cases, you even use the same data. So you don't really need a separate infrastructure for those. You can just as well reuse it. And machine learning engineers then don't have to think about any of it. They just use the golden paths that are defined by MLOps engineers, and they save time. So instead of figuring it all out, getting permissions here and there, getting connectivity to the data, deploying infrastructure themselves, and all of that, they can just rely on the like more platform side of things and use it instead of reinventing the wheel. So that's for me the key difference. That MLOps is focusing more on standardization and focusing on the overlapping patterns across the projects. Like, let's say there are 3 core patterns that we see in deployment and delivery and the data accesses. So for these 3 core patterns, we develop frameworks or tooling around it. And then ML engineers, they see, well, this is the pattern that I have, then I can just use it. But if you have a new pattern, then I guess for one use case, you don't need to create the whole framework. But just as well, you could think, well, I'm developing it now, I can also contribute to another architectural pattern that we have.
Okay, I see. Very similar roles, but like one, for example, the ML engineer would take a fraud detection model and deploy it in production, whereas the MLOps engineer will kind of do this, for example, this template repo structure for different projects that data scientists and ML engineers can use to boost their productivity. So MLOps will impact multiple projects at the same time and standardize things, as you mentioned, whereas ML engineers will work on one project and then move to the other and then move to the other. So, but the 2 jobs are kind of the same, very strongly related, but one is at a single project level and the other one is more, standardized.
Yeah, indeed.
Okay, great, thanks. I think it's an interesting distinction. In many companies, the 2 can probably be the same job. In some companies, if they've got lots of infrastructure, it's probably worth investing in an MLOps team in order to make sure that things are standardized. And it's more like for the long-term vision, things can go faster because you look at different projects, you see what are the similar things, and you try to package things so that the next project will be faster. Yeah. And we actually do this quite a lot in my company because I work in AI and consulting. And so we work on lots of projects. And when we see that for 2 or 3 projects, we had the same issue, we try to package it so that the 4th project will go faster and we won't have this issue anymore. I actually have a colleague who is currently writing a Vertex deployer, which is an accelerator to deploy models on Vertex AI. And I think he wants to release it and to open source it, or maybe it's already done. But he still has to communicate about it. But I find those things very cool. And I think, MLOps engineer is definitely an important job and something that will grow more and more in the future.
No, I agree indeed. It's basically about standardization. I've seen it many times that it is actually accelerating time to production. It makes things significantly faster. But also another aspect that we haven't mentioned is regarding the governance. Especially with this AI Act that we have in European Union, it is important to have overview of all your models in production. And not all companies have it, and I think maybe majority doesn't really have it all in one place. So MLOps frameworks can help with this governance. That it is governed by design if you follow some certain CI/CD use certain CI/CD pipelines or use some tooling. It will, create tags or write data somewhere where it can be accessed by a central monitoring or governance dashboard, where you have all overview of all the models that you have with the links to the repositories and to maybe the last run where you can find it in an orchestration system, and the deployment, where the deployment is happening. So just having it all in one place, it makes it much easier also for everyone. And you can add a lot of things in this kind of dashboards, also costs monitoring possibly, to know how much you spent on certain projects, and also KPI monitoring can be also in the same dashboard. And that's something that I haven't seen that much within organizations. But I think it's very important to have something like that in place.
So I want to move now to the career side of things. Just 2 questions before we finish our conversation. The first one is, this show is called AI Stories. It's all about people and their story. So I'm keen to get one story for you. It can be from you. It can be anything, an experience about a past project, a mistake that you've made, something funny that happened to you. It can be tech related, it can be non-tech related. But could you please share one story?
One story. Oh, that's a good one. I think the whole journey of Marvelous MLOps, it's a story that came out of my career and Bashak's career. Marvelous MLOps, the way how we came up with the name by itself, I think that's a funny story. Well, a year ago, ChatGPT was relatively new, but everyone was experimenting with it, and we asked ChatGPT to come up with a name for an MLOps blog for 2 girls that like Marvel movies. So me and Bashak are both Marvel fans, and that's what ChatGPT came up with, Marvelous MLOps, and our logo is also Marvel inspired. You see also in the background, it's a Lego coming from Marvel, Marvel themed. So we are big fans. We have even Infinity Stone rings, both of us. That's one of the things that is the result of our career, but I think it's a funny story on its own.
Can we expect Marvel content in your next blog then?
We do have some, actually. We do have some Marvel themed memes. Some of them really became popular. One was about using Jupyter notebooks in production, and then there is Thanos saying it's MLOps. So Iron Man, this that Iron Man episode. So that meme became really, really popular. So we do have some Marvel themed memes. I think that's mostly about it, but we don't have Marvel content. Maybe we could do some recommended system with Marvel movies or something. We need to think about it.
Okay, great. Let's just finish the episode with one advice. If you had one advice for people to progress in their career, what would it be? Just one advice.
Yeah, I think if you're just in the beginning of a career, it's good to see a lot of different things. Just try different things, different aspects of data and AI, and understand what you like the most, and then focus on it. So first go broad, and then go deep. And I think that's exactly what I did, and what helped me to figure out what I like the most.
Well, Maria, thanks a lot. It was great to have you on the show and learn from your experience and chat about MLOps. Have a great day and hope to catch up very soon. Thank you.
Thank you. It was really nice, and have a great too.